Hi, I would like to share about motion of an object moving with a constant acceleration in one dimension. So first, let's look at the graphical interpretation. If you have x versus t graph, you should get a linear graph whereby the gradient of the graph is x2 minus x1 per t2 minus t1. So from the gradient, we can get the speed, which is in meter per second. Secondly, if you have v versus t, you should also get a linear graph. The gradient, which is v2 minus v1 over t2 minus t1, and you'll get the acceleration, which is in meter per second squared. Lastly, for the graph of a versus t, you should get a straight or constant line indicating acceleration is constant as time increasing. The mathematical equation can be obtained from graph number 2, which is v minus v naught over t equal to a, and can be rewrite as v equals to v naught plus at. So this is our first kinematic equation. Secondly, from average velocity, v plus v naught divided by 2. Combine this equation with x equal to v times t. So v here referring to v average. So we will get x equals to v plus v naught over 2 multiplied by t. Then we substitute the first kinematic equation into this equation, and it becomes x equal to half v naught plus v naught plus at. This is from the first kinematic equation multiplied by t. And finally, it becomes x equals to v naught t plus half at squared. So this equation is our second kinematic equation. The third equation is derived from x equals to v plus v naught divided by 2t. Now we substitute t from equation number 1. Therefore, it becomes delta x equals to v plus v naught divided by 2 multiplied by equation number 1 of kinematic, v minus v naught over a. Then your equation will be delta x equals to v naught v minus v naught squared plus v squared minus v naught squared, which is can be cancelled out, over 2a. Therefore, our third and final equation of kinematic is equal to v squared equal to v naught squared plus 2a delta x. So these are the three equations that we are going to use in order to solve problems related to motion of an object moving with a constant acceleration in one dimension. Let's try one example. A car covers 40 meters in 8.5 seconds while uniformly slowing down to a final velocity of 2.8 meters per second. A. Find the car's original speed. B. Find its acceleration. Now, in order to solve for this problem, the strategy are: number 1, you need to read the problem. Number 2, you need to draw the diagram, and in your diagram, you need to include coordinate system. You need to also to include initial and final points. Next, you need to include to indicate direction of motion, and lastly, list all the information given in the question. And then you need to select whether you need to use equation number 1 or equation number 2 or equation number 3 to solve for the unknowns. You might need to use 2 equations at one time and do simultaneous equation to find for the unknowns. So the drawing should be look like this. This is the initial point, this is the final point. V initial is not given, V final is 2.8 meter per second. X is equals to 40 meter and t is 8.5 second. Now let's recall our kinematic equation. in order to choose the equation, V naught is in all the equation. But in order to use any equation, we need to have acceleration which is not given. Therefore, we need to use two equations to find V naught. Select equation number 1 and equation number 3. From equation number 1, A is equal to V minus V naught over T. And delta X equals to V naught T plus half. We substitute acceleration from equation number 1, T squared. So this one T is cancelled out by this T. It is then become delta X equals to V naught T plus half Vt minus half V naught T. So the one that I circle can be minus. So it becomes delta X equals to half V naught T plus half Vt. Then we bring V naught as our subject, and it becomes equal to delta X minus half Vt, and 2 and T becomes 2 over T. After substituting all the information we have, we get original velocity is 6.61 meter per second. For question B, find its acceleration. Recall all equation. We already have all the information, so you can use any one of the equation. But this time, I use equation number 1. So substitute into the equation, and you get A equals to negative 0.4482 meter per second squared. You may try to get the acceleration by using equation number 2 or equation number 3 on your own. The negative sign in your answer indicating that acceleration and velocity are directed in opposite direction, which means that the car is slowing down. This diagram is showing the motion diagram of the previous problem. As you can see, the initial velocity is 6.61 meter per second. The final velocity is 2.8 meter per second. You can see that the vector diagram is longer compared to this one, which means that the magnitude is smaller. The direction of acceleration is opposite to the direction of the velocity, and the magnitude of the vector is the same since acceleration is constant. For example number 2, a truck starts from rest and travels for 5 seconds with a uniform acceleration of positive 1.5 meter per second squared. The driver then applies the brake, causing a uniform acceleration of negative 2 meter per second. If the brake is applied for 3 seconds, A, how fast is the truck going at the end of the braking period? Choosing equation number 1, substitute in the equation, you get V1, which is 0 plus 1.5 meter per second multiplied by 5 seconds. And V1 is equal to 7.5 meter per second. So this is the speed at the end of the first part. Next, we use the same equation to calculate V2, which is at the end of the braking period. So the initial velocity of the second part would be the final velocity of the first part. So we take 7.5 meter per second to be our initial velocity, and the acceleration on the second part is negative 2 meter per second, and the time where the driver apply the brake is only for 3 seconds, which is 8 minus 5 seconds. Then you get V2 equals to 1.5 meter per second. Question B is asking, how far has the truck gone? Which means that we need to calculate X in part 1 and X in part 2. For this problem, let's choose equation number 3. For part 1, X1 equal to V naught T plus half AT squared. So you get 18.75 meter. For part B, you get V naught T plus half AT squared, and you get 13.5 meter. So altogether, the truck has gone 18.75 plus 13.5 meter, which is total 32.25 meter. Alternatingly, I want to show you if you choose equation number 2 instead of number 3 to solve for this question. So, we take v squared equal to v naught squared plus 2a delta x. Then, rewrite as delta x equals to v squared minus v naught squared over 2a. Substitute into the equation for part 1. V final minus v initial over 2 multiplied by acceleration, and you get 18.75 meter. For part 2, x2 is equal to 1.5 meter per second squared minus 7.5 meter per second squared divided by 2 negative 2 meter per second squared, and get 13.5 meter. It is exactly the same if you choose equation number 3. Equation number 1 cannot be used in order to solve for these problems because it doesn't have delta x.